Thank you for the opportunity you have given to me to present this course on Introduction to Statistics and Probability. My name is Aling Emmanuel and my email address is blinga2002ug@yahoo.co.uk and my mobile number is 078 91 75 989. Thank you. Probability. What do we understand when we talk about probability? Probability is just chance. What is the chance that it will rain tomorrow? We could say, what is the probability that it will rain tomorrow? So when we talk about probability, we talk about chance. Note that a set of all possible outcomes of a statistical experiment is called a sample space and is represented by S. And each outcome in a sample is called an element. So let S be comprised of elements H and T. Be an example of tossing a coin where a head or a tail appears. Suppose this coin is flipped the second time and a die is tossed if a tail is observed. Then the probability tree will be as shown in the next slide. Here we can see that a die is tossed at first, we get a head or a tail, and the second time, a coin is tossed on the first time and a head or a tail is observed, and a coin is flipped the second time and when a head appears, else a die is tossed when a tail appears. And you can see that these are the elements of tossing a die when a tail appears in the first flipping of a coin where a tail appears. So our sample space S is given by this set. It will be a head and a head and a tail and 1, a tail and 2, a tail and 3, a tail and 4, a tail and 5, a tail and 6. So the total number of elements in this sample space is 1, 2, 3, 4, 5, 6, 7, 8. So the total number of elements in this sample space is 8. And each of these are elements of this sample space, of this statistical experiment. Suppose we have a sample space S which contains X and Y such that the sum of X and Y is less than or equal to 4. So we refer to this sign as the conditional sample space. This symbol here represents the condition, and X plus Y is the what? Is the condition that, or the criteria that is being given for this sample space that contains X and what? And Y. what is an event? An event is a subset of a sample space, while a complement of an event A is represented as A with this sign such that they are not in A. If you have your element as A, your sample space as A, and the elements that are not in the sample space A is called the complement of what? Of A. The intersection of two elements A and B is denoted by A intersection B. Is the event containing both elements that are common to A and B. And we should note that two events A and B are mutually exclusive or disjoint if their intersection is an empty set. That is to say, A and B have no elements in common. If A and B do not have any intersection set, then they are mutually exclusive or disjoint. And then the union of two elements denoted by A union B is the event. Is the event containing all elements belonging to A or B or both A and what? And B. So we need to understand sample space, element, a complement, intersection, mutually exclusive events, and union of what? Of events. Now we are going to learn about counting sample points. If an operation can be performed in n1 ways, and if for each of these ways a second operation can be performed in n2 ways, then the two operations can be performed in n1 times n2. In other words, the two operations can be performed by obtaining the product of n1 and n2. For example, how many points are there in the sample space when a pair of die is thrown once? Solution. So let n1 be the number of events, possible events when the first die is thrown, which is equal to 6, and let n2 be equal to the possible number of elements that can be shown when the second die is thrown. Then the possible ways is going to be the product of n1 and n2, which is going to be 6 times 6, which is equal to 36 what? Possible ways. A developer of a new division offers prospective home buyers a choice of either Tudor, rustic, colonial, and traditional exterior styling in ranch, two-story, and split level floor plans. In how many ways can a buyer order one of these homes? Solution. Remember, this developer offers prospective home buyers choices of exterior styling, and there are 1, 2, 3, and 4 exterior styling. Okay, there are 4 of them. Then the floor plans, there are 3: ranch, two-story, and split level floor plans. So for you to choose, you first have to choose the exterior styling and you choose the floor plans. For you to do that, for you to choose the exterior styling, there are 4 different ways of doing that. 4 different ways of doing that. And then the floor plans, there are 3 ways. Therefore, the possible homes can be shown using a tree diagram. However, the possible homes that can be chosen is equal to 4 times 3, which is equal to 12 possible homes that the home buyer is able to choose from. If an operation can be performed in n1 ways, and if for each of these a second operation can be performed in n2 ways, and for each of these first 2 a third operation can be performed in n3 ways, and so forth, then the sequence of k operators can be performed in n1 times n2 times n3 times dash 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 times nk ways. Permutation. What is permutation? Permutation is an arrangement of all or part of a set of objects. For any non-negative integer n factorial is defined as the product of n times n minus 1 times dash 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 times 2 times 1. So when you are to compute n, the permutation of n, you have to compute n factorial. Okay? And the number of permutation of n distinct objects taken r at a time is given by n pr, n permutation r, which is equal to n factorial divided by n minus r factorial. For example, in 1 year, 3 awards, which is research, teaching, and service, will be given to a class of 25 graduate students in statistics department. If each student can receive at most 1 award, how many possible selections are there? Remember, there are 3 awards and there are 25 graduate students. So this example is testing you how you can apply permutation of selecting objects such that R is selected at a time. So the total number of sample points is going to be 25 permutation 3. 25 students that selected 3 different choices, either research, teaching, or service. And this can be done in 25 permutation 3 ways, which is equal to 25 factorial over 25 minus 3 factorial, which is equal to 13,800 and what? And 50. The number of permutations of n objects arranged in a circle is n minus 1 factorial. The number of distinct permutations of n things, of which n1 are of one kind, n2 of a second time, and nk is of a kth kind, is given by